guys, today I'm going to work through the two examples from exercise 4.3, which is logarithmic scales, from the Year 12 Jacplus textbook. So it shouldn't take too long, I don't think. This first one, they're talking about loudness in decimals and how it's related to the intensity of sound. And this is the equation we use to relate the two. And they're saying where I0 is equal to 10 to the power of negative 12 watts per square metre. And this value is the lowest intensity of sound that can be heard by human ears. Right, that's not really too important for us to consider in the equation, just some added information there. An ordinary conversation has a loudness of 60 decibels. Calculate the intensity in watts per metre squared. All right, so let's see our formula. I'll just rewrite it over here. And look, I might just put the I0 in straight away, which is going to be 10 to the negative 12. And they're saying the loudness of the ordinary conversation is 60 decibels, so I can put that in as well. All right, so now we're trying to solve for intensity. So we're going to have to do some rearranging. So I'm going to divide by 10 on both sides. So I get log 10 I over 10 to the 12, or neg 12, equals 6. And then, well, now I'm going to take that 10 here and undo the log, which will give me I over 10 to the negative 12 equals 10 to the power of 6. And this 10 to the power of negative 12 in the denominator, well, this is I times 10 to the power of 12. So remember, if we move it from the denominator into the numerator, or vice versa, it will change its sign. So this is a negative in here, so by taking it out of the denominator, it means it's a positive 12 in the power. So I is going to equal 10 to the 6 over 10 to the 12, which is 6 minus 12 is negative 6, so 10 to the negative 6, and our units are watt per metre squared. So that will be our final answer. All right, so look, let's move to the next one. And it's using the same formula as we did in the previous example. If the intensity is doubled, what is the change in the loudness? Correct 2 decimal places. So our formula being 10 log 10 I over I0. And that's loudness equals that. Now, so I'm going to think of this in terms of two different equations. So the first one will represent the original loudness, and the second will represent the loudness once we double the intensity. So I'm going to call this L1, and that would mean that the intensity here is L1 as well, is I1. And well, now I can say L1 equals 10 log 10, and remember I0 is 10 to the power of neg 12, so that means we've got 10 to the power of 12 times I1 here. And for the meantime, I'll leave that. Let's go to L2. So L2 is when we are doubling the intensity, so it's 2 times the original intensity. So we have 10 log 10 to I1, so 2 times I1 there, which equals I2. So really I probably should have written I2 equals 2 times I1. And so that's why I've written that there, and then that's over 10 to the neg 12. So my equation for L2 will be 10 log 10 to I1 times 10 to the 12. Now, we have two equations here, and look, there's no further information that we can put in, but what we see is that they're not very helpful. So this one and this one here, it's not very helpful because we can't see how much the change in loudness will be. So what I'm going to do, and you might already have sort of looked ahead and thought this, because there's a multiplication here, we can use log laws, and we can do that for both of them. So I'm going to rewrite L1, and I'm going to write that as 10 log 10 and 10 to the 12 plus 10 log 10 I1. So all I've done there is break them down into two parts. If we had these two equations, if we had these two together like this with the plus, we would know that we've got to multiply them. But in this case, we've broken it into two parts. And then, I'm going to take this 12 out of the power. So often putting things into the power is helpful, but in this case, it's actually more helpful to take it out of the power. All right, so let's have a look. This log 10, 10 is of course 1. So 120 times 1 is just 120 plus 10 log 10i. And that's all I can do at this point. So I'm just going to highlight that because we don't want to lose it there. And now I'm going to look at L2. So L2, and we know L2 is given by 10 log 10 2i1 times 10 to the 12. So let's break it down in the same way. So L2 equals 10 log 10 2. And remember that it's 2 times I, so it's another one where we can break it down into an addition of logs there, plus 10 log 10i, 1 I should say, plus 10 log 10, 10 to the 12. So let's take this out of the power again like we did before. We've got L2 equals 10 log 10 2 plus 10 log 10i plus 120 log 10 10, which is just 1. So for the same reason we did before, we get 120 there. And now we can compare the two equations. So I'll just make it so we can see both of them. So we can see these are our two equations here. And we're looking for the difference. So what is the change in loudness? So we want to see what's the difference between the two. Well, we've got 120 in this one, we've got 120 in this one. We've got 10 log 10i in this, we've got 10 log 10i in this. Another way you could look at it would be to say the difference, or the change in loudness, is L2 take away L1. And all that's left over is 10 log 10 2 decibels. And look, I should probably do this in decimal places as they've asked, so I'll just quickly do that on my CAS. Okay, so we get 3.01 decibels, rounded to 2 decimal places. So that would be our final answer. And that completes the worked examples from 3.3, 4.3 I should say.